Moving on to binomial expansions. This is question 5. We are told to find the coefficient of x squared. So that means if I were to expand this, that means I'm multiplying this bracket by itself 5 times. And when I expand it, I want to know what is the coefficient of the term that has x squared. That's basically what the question is asking. Okay, so we use the binomial theorem here. The binomial theorem is one that you should know. It's not very difficult to remember. So the way the binomial theorem works is that any term, you want to find the nth term. So here I say the nth term in the binomial expansion. Because here I am raising it to the power of 5, it is 5, choose n. Okay, so in a previous question I showed you how to work this out. 5, choose n, and then this term here that comes first, that is my a, so I say 1 over x squared, and then I have 5 minus n. And then the second term, it's positive, so I don't need to write the plus there. If it was negative, I would put the negative in there as well. And then this is 3x to the power of n. Okay, so if I want the first term here, I will put 1. There I will put 1. Sorry, if I want the first term we start with n is 0. So this expansion will have 6 terms in it. You have the term where n is 0, n is 1, 2, 3, 4, up until 5. So the first term, n is 0. So I will put 0 here, 0 there, and 0 there. If I want the fourth term, that means it's 0, 1, 2, 3. N is equal to 3. Then I put 3 here, 3 there, 3 there, and then I just multiply it out. So it's very simple and easy to do, especially if I'm just asking you to find a specific term instead of finding the entire expansion. In fact, it's even easier with finding an entire expansion compared to Pascal's triangle, or actually multiplying this bracket by itself 5 times, which could take you a very long time. Okay, so what we want is the term that has the coefficient of x squared. Now you can see this has x and that has x. So somehow when I multiply these two together, they should combine, and the exponent of x should be 2. So what I'm interested in now is this part over there. So I'm going to pull it out and then work with my coefficients and make sure that the coefficient, or the final coefficient, is 2. So the way I do it is this part here. I'm going to extract it and bring it over here. Okay, so I have 1 over x squared to the power of 5 minus n, and then I multiply this by 3x to the power of n. Okay, so we know how to use our laws of exponents. You should be familiar with them. If I have a quotient like I do over here, raised to a power, I can distribute the exponent. The numerator gets the exponent, the denominator gets the exponent. But you can see over here the numerator is 1. So if I say 1 to any power, it remains as 1. Okay, so when I multiply out the brackets, here I will have 1 over x to the power of 2 times 5 minus n. And then here I have 3 to the power of n, x to the power of n. So just like I distributed my exponent in the numerator and the denominator, I didn't write it here. Like I said, 1 raised to anything just remains 1. So there's no need to write like 1 to the power of 5 minus n. The final answer is still going to be 1. And then here, when it's x squared raised to this power, I need to multiply those exponents. And here the 3 gets the n, the x gets the n. Okay, so when I work this out, what do I have here? Here I have 1 over x to the power of 10 minus 2n, and then 3 to the power of n, x to the power of n. Now you always have to keep in mind what I'm working towards. I want the final power of x to be equal to 2. Okay, so I will combine these two. So I'll have 3 to the power of n, x to the power of n minus 10 minus 2n. Okay, so I brought everything to the numerator and combined the exponents of x. So here, this x is in the numerator, this one is in the denominator. That means they are dividing. So I say x to the power of n minus, because of the division, that's the laws of exponents, and I put it in brackets to show that I'm subtracting the entire thing, not just the 10. So I don't say minus 10 with and then minus 2n without the brackets. That is something completely different. Okay, I'm gonna shift this up just a scotch. Okay, so we continue. I'm gonna simplify the exponent of x just to see what I get. So here I have 3 to the power of n, x to the power of n minus 10 minus negative 2. So remember, there's an invisible 1 over here, and this must multiply everything. So this is n minus 10 plus 2n. So this is 3 to the power of n, x to the power of 3n minus 10. Okay, so you can see what I have over here, 3n minus 10, and that 3n minus 10 must be equal to 2 because I want the coefficient of x squared. I'm going to write it over here just to space, but when you write it in your exams, let it just flow downwards here, because I don't have much space. It looks a little haphazard, but when you write it, please go down like that. Okay, so remember, I want the coefficient of x squared. So because I want the coefficient of x squared, the exponent over here is 2. So 3n minus 10 has to be equal to 2, because that is the only way I will get the coefficient of x squared. Okay, so when I solve this, you know how to solve this. Everything with n on one side, everything without n on the other side. So I add 10 on both sides. Let's say plus 10 plus 10. I have 3n is equal to 12. And then I divide by 3 on both sides. Divide by 3, divide by 3. I get n is equal to 4. I hope that is correct. Okay, so n is equal to 4. Now you need to remember the question. The question said, what is the coefficient of x squared? So what I need to do is go back to my formula for the nth or the term in the binomial expansion, and then substitute n and then work out what the coefficient is. Okay, so if n is equal to 4, that means this is term number 5, because with the first term n is 0, then n is 1, n is 2. Okay, so just divide this. Again, remember, your work should flow downwards. I'm just trying to use all the space that I have over here. You'll have plenty of paper in the exam, don't worry about it. Just write neatly. It's much easier to mark when it's like that. Okay, so I'll write down the formula of the binomial term. This is 5, choose 4, because n is 4. And then we said it is 1 over x squared to the power of 5 minus 4, and then 3x to the power of 4. Okay, so now that everything I did was just to work out what this n is there. And then after I worked it out, we said n is 4. Now I substituted into this formula to get the coefficient, because the question didn't say work out n. There's no n in the formula, or there's no n in the question. We just want the coefficient of the term that has x squared. Okay, so we multiply this 5 choose 4. Remember what 5 choose 4 means? It means if I have 5 people, how many different ways can I pick teams of 4 out of those 5 people? So you can try it. 5 isn't such a big number, and it'll help you understanding or learning about it if you actually do work it out. But you should know the formula. This one here, I'm just going to, this is 5 factorial over 4 factorial, 1 factorial. Okay, and then this one over here, this is 1 over x squared to the power of 1, and then 3x to the power of 4. Okay, so I've just simplified this over here, there, and then this one, the definition. Okay, so this I would work it out. So I'm gonna, might look a little bit confusing, but I hope you can follow. I'm just trying to use all the space that I have over here. So 5 factorial over 4 factorial times 1 factorial. Remember, 5 factorial is 5 times 4 times 3 times 2 times 1. So 5 factorial is simply 5 times 4 factorial. Because remember, factorial means, here, when I say 4 factorial, it means 4 times 3 times 2 times 1. So I can shorten it. And the reason I stop here is because in the denominator, I have a 4 factorial. And I want them to cancel. So they do cancel. And then the second term, or the second part, is x squared. And then here I have 3x to the power 4. Remember, the 3 should also get the exponent 4. So it's 3 to the power 4, which is 81. And then x to the power of 4. Okay, so don't forget about the 3, because the 3 forms part of the coefficient. So we've done all this work. We've done everything correctly. And then just to mess up over there, that seems like a waste. Okay, so we can look at our numbers. I have 5 and I have 81. So multiply that on your calculator. I think you should get, is it 405? And then this coefficient is obviously going to be x to the power of 2. Because look over here, I have x to the power of 4 divided by x to the power of 2. That is obviously just x to the power of 2 that is left. So you can just make the statement, the coefficient is 405. So remember, coefficient is the number in front of the variable, and here you've shown that the coefficient is 405.